guys, happy Monday. As you know and can see, I'm not here. So I have put together this video for you as promised on how to graph the last two trigonometric functions we haven't talked about yet, tangent and cotangent. And so if you'll remember, last week we spent some time graphing sine and cosine, and then cosecant and secant. And you'll find today that tangent and cotangent are a little bit, actually quite a bit different than graphing the other four. Now, something they do have in common with secant and cosecant is that they do have vertical asymptotes because of the fact that they are fractional functions. So secant and cosecant were reciprocal functions. Cosecant is 1 over sine, and secant is 1 over cosine. So wherever the denominator could equal 0 or would equal 0 will be vertical asymptotes. Now, tangent and cotangent are similar in that they are fractions. Sine over cosine is tangent, which you'll see here, and cotangent is cosine over sine. So wherever the denominator equals 0 for these functions, we will get vertical asymptotes. So how about your parent function sheet and your notes, and let's get going. We're going to start right away here with the tangent function, and as I just said, tangent is sine over cosine. And so when does a fraction equal 0? Well, that's when the numerator equals 0. So we will have x-intercepts at the locations where sine of x is 0, which if you look at your unit circle, which is something you should maybe also have in front of you for quick reference, sine is the y-coordinate, and so it is 0 at multiples of 0 and pi and 2 pi. So 0, pi, 2 pi, 3 pi, and the negative multiples as well. So we'll have x-intercepts there. And then as far as vertical asymptotes go, vertical asymptotes will go where the denominator equals 0, and so in this case, where cosine is 0. So cosine is the x-coordinate, and that is 0 at pi over 2, 3 pi over 2, or negative pi over 2 and negative 3 pi over 2. So odd multiples of pi over 2. So that'll be where the vertical asymptotes go. Now, here is the graph of tangent. And so it looks kind of different than the graphs that we've already seen, but you can see here the vertical asymptotes are placed. And it almost looks like a cubic curve, but it curves in the positive direction. So it's increasing from lower left to upper right in each period. The other big difference that I should also mention between tangent and cotangent graphs and the other ones is that the period is pi, not 2 pi. So something to keep in the back of your mind when we get to doing some period changes in a minute. So this is the graph of tangent. You might want to pause the video so that you can get this graphed on your parent function sheet. And then we'll take a look at cotangent. Okay, cotangent. Now, cotangent is the reciprocal of tangent. So cotangent is the reciprocal of tangent. So if tangent is sine over cosine, then cotangent is cosine over sine. So it'll kind of be the reverse here for x-intercepts and vertical asymptotes. Since the numerator is cosine, cotangent will have x-intercepts where cosine is 0. And since the denominator is sine, cotangent will have vertical asymptotes where the sine is 0. The other big difference is the direction in which the branches go. They almost appear to be negative in nature, or they decrease from left to right. So that is what is different from the tangent graph. Similarly, though, the period of cotangent is pi. So something to keep in mind. Okay, so you can see here we have x-intercepts where the cosine is 0, like pi over 2, 3 pi over 2, negative pi over 2. And we have vertical asymptotes where the sine is 0. So 0, pi, 2 pi. Okay. You can, again, pause the video for a moment here if you want to sketch this on your parent function sheet. Okay. We are going to take a look at 3 examples of transformed functions. So I already have my graph up here, but don't pay attention to that just yet. Let's talk about the function. F of x equals negative tangent of 2x. I suppose the other thing I should mention about tangent and cotangent is that since the range is unrestricted, meaning these branches go from negative infinity to infinity as far as the range is concerned, amplitude is not really a thing with tangent and cotangent graphs. Because we know that for like sine and cosine, the amplitude bounds the range, but we don't have that here. So amplitude is not something that we are going to identify for our tangent and cotangent graphs. So when I start with graphing this function, I'm going to start by identifying period and any phase shift or vertical shift, and in this case it looks like we have a reflection. So the period of this graph starts as pi, but is being divided by 2. The period is pi over 2. There is no phase shift, there is no vertical shift. However, that negative in front does tell me that this is going to be reflected. So the branches will take the shape more of the cotangent graph. However, all of the rest of our information is going to come from this being a tangent graph. And what I mean by that is that negative tangent of 2x is actually negative sine of 2x over cosine of 2x. That's how we could rewrite that. And why that's important is because that's what's going to help us identify intercepts and asymptotes. Most importantly are the asymptotes. So asymptotes come from things that make the denominator 0, since we know the denominator can't be 0. So in this case, we want to know where the cosine of 2x will equal 0. Now I start with just where on one rotation of the unit circle cosine is 0. And so that would be where the x-coordinate is 0, so pi over 2 and 3 pi over 2. So we're going to say 2x is 3 pi over 2 and pi over 2. I have to go through this just to flip this. So we'll go over here first. If I divide by 2, pi over 2 divided by 2 is pi over 4. And if I divide by 2 over here, 3 pi over 2 divided by 2 is 3 pi over 4. So we're going to have vertical asymptotes at pi over 4 and 3 pi over 4. And also the negative pi over 4 and negative 3 pi over 4. Since cosine would have been 0 at negative pi over 2, which is 3 pi over 2, and negative 3 pi over 2, which is pi over 2. And so even though the period is in this case it's pi over 2, I actually am going to have 4 well-defined, well, 3, maybe 4 or 5 well-defined periods of this graph graphed. Just because I feel like if I would have bounded myself to just pi over 2 in the positive and negative direction, that sometimes it gets a little funky if you don't graph multiple periods of tangent and cotangent. So anyway, our x-intercepts will be right in the middle of the asymptotes. And then tangent would generally increase from left to right, but again, because of that reflection, it's going to decrease from left to right. It's going to look something like this. And this here is 3 full periods. You can graph the 2 on either side of the farthest asymptotes, but I'm not going to because 3 is good for me. Okay, let's look at another one. Here we have tangent of x minus pi over 2 minus 1. Now you can see that my scale on this graph is a little bit different, and I'll talk about that when we get there. But let's start with identifying key pieces of information. So first of all, period this time is not changing, so it's pi. But we do have a phase shift, pi over 2 to the right and a vertical shift down 1. Now, vertical shifts on tangent and cotangent aren't super crazy important. They do take that x-intercept and shift it down 1, so it's no longer an x-intercept, but it is still kind of that point at which the branch curves or changes. We call that a point of inflection in calculus, but it changes kind of the concavity of the graph. So that will be shifted down 1. But now the important part here is figuring out where the vertical asymptotes are going to be. So there's kind of 2 different ways you can think about this. Again, it's really important to remember that tangent is sine over cosine. So in this case, the vertical asymptotes are going to be where the cosine of x minus pi over 2 is 0. So you could think of where the cosine is 0 and then just shift those pi over 2 to the right. Or the algebraic approach, similar to what we did in the last example, would be to figure out where is the cosine of x minus pi over 2 equal to 0, and then solve for x. So on the unit circle, 1 rotation, 0 to 2 pi, cosine is 0, where the x-coordinate is 0. So pi over 2, 3 pi over 2, or negative pi over 2, negative 3 pi over 2. And so I'm going to say x minus pi over 2 equals pi over 2. And x minus pi over 2 equals pi over 2. So first we should go to a simple minus. So maybe I will put those there to keep that in mind when we're solving. So if I add pi over 2 here, pi over 2 plus pi over 2 is 2 pi over 2, which is pi. And if I add pi over 2 here, 3 pi over 2 plus pi over 2 would be 4 pi over 2, which is 2 pi. Now the plus or minus thing was important there because we're going to have vertical asymptotes at pi and 2 pi, which is why I scaled my graph to go to 2 pi on both sides. Again, we'll have a lot of periods shown here. Plus or minus negative pi and negative 2 pi. So you can see here we're putting vertical asymptotes at multiples of pi. So the other important piece to keep in mind is that 0 is a multiple of 2 pi. And that should be quite obvious because, well, 0 times pi would make it a multiple of pi. But also, 0 is coterminal with 2 pi. So 2 pi is an asymptote and 0 must be an asymptote. Okay? And then the other thing we have to do with this graph is this shift down 1 is important because, again, that's kind of where that turning point of each branch will be. So I'm going to put that point in here between my asymptotes. And this tangent is not reflected, so it's going to take normal shape, increasing from left to right. And of course, it follows the asymptotes, but doesn't cross them. And I've got 4 full periods graphed here, so that is plenty. Okay. So tangent of x minus pi over 2 minus 1. Okay, one more. We have here a cotangent graph this time. Again, I have my scale up here from 0 to pi in both directions, and we'll talk about why when we get there. But just like the other one, the first thing I'm going to do is identify transformations. So period is pi. Don't make that mistake. And it does not have a period change, so it's going to stay pi. We have another phase shift, this time pi over 4 to the left, and a vertical shift up to. Okay. Other thing to keep in mind, cotangent is cosine over sine. So that's going to play a role in finding our asymptotes. So this time we're looking for where the sine is 0 and then shifting those left pi over 4, or where the sine of x plus pi over 4 is 0. We can solve for them this way. So I'm going to again get values on 1 rotation of the unit circle from 0 to 2 pi on where sine is 0. So sine is the y coordinate, and it is 0 at 0, pi, and 2 pi. probably hear my pen clicking on the screen here, sorry about that. And now I'm going to subtract pi over 4. So here I get negative pi over 4. Pi minus pi over 4 would be 4 pi over 4 minus pi over 4, which is 2 pi over 4. And then 2 pi would be 8 pi over 4 minus pi over 4 is 7 pi over 4. This is kind of past the domain that I'm graphing on. So I'm going to go ahead and sketch these on, and then it should also make sense here that negative pi over 4 and negative 3 pi over 4 will be vertical asymptotes. And this is shifted up 2, so we'll keep that in mind when we graph each branch. And it's cotangent, so this time the branches flip so that they decrease from left to right. So I'm going to kind of put in that turning point, or longer and x-intercept, and then graph from left to right. My branches here decreasing. Okay, so 3 full periods on that one, and that should be good. So it's really not too difficult once you get the hang of it. You just have to make sure that you place your vertical asymptotes properly, and then from there it's pretty simple. Okay. All right. This table here, I believe I put this at the top of your parent function sheet. This just kind of lays out all of the information about all 6 functions in one spot, as far as what the period is, what the domain and range are, asymptotes and zeros. So those are important to take a look at. And then here is the assignment. Now, certainly we talked about this on Friday and you have it on your chapter guide, but hopefully you took some time over the weekend to get started on it, especially the, well, mainly the cosecant and secant part of it, since that's what we did Friday. So you can use the rest of the time now today to work on the remaining 4 or 5 questions left that were geared towards tangent and cotangent. And then also, as part of your assignment, you should study all of the graphs, because tomorrow, if you are second hour, and Wednesday for 8th hour, you are going to have a short, quick graphing quiz. I think there are 6 graphs on that. So it is not a big formal quiz, but it is just a quick, can you do these 6 graphs? A couple of them might be parent functions, a handful of them have transformations, so you'll have to identify things like amplitude, period, phase shift, vertical shift, maxes, mins. We looked at how to write the range of like the secant and cosecant functions. So study those tonight. When you're only going to get about 25 minutes of the block to do that. The rest of the block, we'll do some practice before the quiz, but don't wait until that time to really start looking at that information, because at 25 minutes then will definitely not be enough to take that quiz if you're not prepared. So definitely take some time to study tonight before you come to class on the block day for that little mini quiz on graphing, okay? You can feel free to email me if you have any questions. You can also Google, check out Khan Academy. I'm sure there's some cool graphing trig function videos on there if you feel like you need more explanation. But also, I'll be here early on Tuesday to answer any questions if you want to come in before school. Otherwise, just make sure you're practicing and looking over all of your graphing materials, as well as having that unit circle and your quadrantals memorized, because you see how important that is for graphing. Really, it always comes down to just using the quadrantals if you set yourself up to do that, like we had been doing in class. All right? So with that, I'm going to leave you to get to it. You should have at least 20-25 minutes here in class to work on the rest of that assignment. And like I said, send me an email if you need anything. Otherwise, I will see you guys tomorrow and on Wednesday. All right. Have a good Monday.